Hello, I'm Kai-Xing. Recently, Rakuten shared with us a very interesting research they are doing, and you can see a title here. I'll be running through the slide deck presented by the researcher. You can check out the full slide deck in the link below. So the whole purpose of this research is to kind of identify if we can use ingredients to, in a way, categorize recipes. So let's say we have a prawn noodle recipe. We know that prawn is, for example, one of the key ingredients in this recipe. So we will like categorize it as a prawn related recipe. You can imagine this will be very useful in things like search engine. If I search for prawn, maybe I'd like to see a whole list of all the prawn related recipes. Now for the motivation. Here you can see that this drumstick equals to chicken leg. So this is one of the key concepts, for example, of explaining text analytics, some of the challenges. There is a lot of variations, misspellings, similar words, similar meanings. And we need to know that drumsticks equals to chicken legs in this context of food. And it's not easy, especially for Japanese language, because there are three variations of writing the same word. And it of course compound with the fact that the language itself is very different from the structure. It's very different from the English language that most of us are familiar with. And here's the goal. So there is, the first thing is of course synonyms. Salmon, Japanese salmon, same thing. Shrimp, tiger prawn. Shrimp and tiger prawns are not the same thing, but they are the same category of things. So you want to put them together. And the end result is what we mentioned before. When someone search for tiger prawn, we like to return results for shrimps in a related category, in recommended things to check out. And what happens here is, I can't read Japanese, so I can't help you here. So what happens here is, so these are hyponyms, related things, synonyms, same things. And here are some related work that has been done in the research. One, especially Wikipedia. Wikipedia has been used widely in many research. We'll have a more detailed example to see later. But people kind of like make use of the structure of Wikipedia where related links are grouped, related articles are grouped together, and we can use that structure to actually help our model learn text analytics. Here's the approach that the author used. It's a very interesting approach. So what she's assuming is, and what is of course through trial and error, she found out that the first ingredient of the recipe is actually the most important, the most representative ingredient for the category. What this means is, for example, imagine this prawn. If prawn is the first ingredient on the list, it's very likely that the entire recipe is about prawn. Prawn is the most important ingredient. And this is what basically just based on what she observed. Among 200 recipes, about 90% listed their main ingredient as the first position. So this is a very simple algorithm. Not a very like breakthrough mathematics formula. We just look at the first ingredient and use that to decide what category do we put this recipe under. Here's the data that she's used to test, and here's the scoring strategy. So comparing the first ingredient, so this is the strategy she's proposing, versus two other common strategy. Frequency, you literally count the number of times prawn appears, and yeah, if prawn is appears very often, so it's high frequency item. TF-IDF improves on that, so we are not just concerned about the frequency of the item. We are concerned if in prawn related recipes prawn appear, but in things that is not prawn related, chicken soup, ginseng, or some vegetarian dish, for example, prawn shouldn't appear and prawn didn't appear. So prawn, it only appears in certain recipes, and in those recipes is a prawn related dish, and then TF-IDF will be high in that case, because prawn is very kind of like very indicative. Once it appears, it's pretty much confirmed it's a prawn related dish. It's very indicative. And here's the scoring strategy, in the sense that these three lines show how it's calculated, how the three different methods are calculated. And I'll skip through some of these slides about more of the details of the experiment, but categorization, and I'll show you the result. In summary, the FI is the first ingredient method, has the best F score and the highest recall. I'll show you a comparison. Okay, this is the Wikipedia. So this is a Wikipedia structure that we mentioned before, that we make use of. For example, we search for prawn, and then they'll break down into the numerous kind of like related articles about prawn. So you can use this structure to mine out the text analytics. Now here's the summary. It's very interesting to see. For example, imagine we are doing a search engine. We search for prawn. Using the frequency method, what we end up with is salt, as because salt is the highest frequency appears in every single ingredient. It becomes salt will become first, and your shrimp, the only prawn related thing, will come down all the way at the bottom here. Compared to TF-IDF, so TF-IDF correctly identified shrimp, different variations of shrimp, but look at the score, huge variation. The shrimp itself is ranked a good score, but the difference between the next variation of shrimps, huge variation. And even like things like potato starch. Why potato starch appear in TF-IDF? Because you see, there is a dish that uses ketchup and potato starch. So it's true that ketchup and potato starch appears in shrimp related dish, but again, this is not what we want. We want only to have shrimp results being returned. And if that's what we want, the first ingredient method that the author proposed seems to work very well. Look at this. Everything is all prawn and shrimp related, and the score is very good. The score is all quite close to each other. So imagine again, if a search engine, you use the first ingredient method, it will give you everything that's related to your search result. That's great. And this is what the conclusion is. So what we see from this research is that it's not just about shrimps. It's also about the fact that how we can make use of the structure of the question. In this particular question, we're trying to solve recipes, text mine recipes, Japanese recipes to be precise. And this structure of the first ingredient being the most important, most representative ingredient becomes very important, and it's kind of like fully, you can say, abused, fully exploited by the author to have a much better solution than a normal off-the-shelf solution like TF-IDF frequency. We use TF-IDF very often as a kind of off-the-shelf or even a baseline comparison. And the author made use of the structure to create a new and very simple, very fast method that outperforms this off-the-shelf result. And this is the kind of like thinking that we need for analysis, especially when we want to build cutting-edge models, we want to build like new analysis, faster, better analysis, that we do not need a lot of complex mathematics, but we need to understand the data and the structure. Okay, so that is pretty much what we covered the content of this slide deck, and I guess we'll see you in the next new video and other videos. Bye bye.